Hello, and welcome to the first of 3 videos in this story-based science lesson masterclass for teachers of early childhood education. I know what it's like to be an early childhood teacher. Working with little kids is challenging. Classes can be chaotic, budgets can be tight, and time is limited. So I'm here to tell you about an innovative way to tackle many of these issues. Let me start with an introduction. My name is Aino, and I am from Kide Science. We are a story-based learning education resource built by teachers for teachers. I've spent the better part of my life evangelizing the ways in which play enhances learning. I'm a former teacher myself, and I'm on a mission to spread the word of story-based STEAM education anywhere I can. The purpose for these videos is to share what our research has shown to be one of the most effective ways to teach science: storytelling and play-based learning. What I am going to share with you throughout this masterclass is based on actual data, research that has been conducted over the years and has touched the lives of children all over the world. But you don't have to take my word for it. You will be given the sources of the research that can be found in the attachments, along with real-life example of these lessons in action. The purpose of this masterclass is to help you get started in teaching some of the most engaging, fulfilling science lessons possible, to help you get your students excited about learning. This less than 30-minute masterclass will take place in 3 modules. First, the introduction, which is this video, and an overview of story-based and play-based learning. You will learn the benefits of bringing story-based learning into your classroom, including how story-based learning encourages scientific process skills in little ones compared to just teaching hard skills. The second, which is about drama. It's a lot more useful and easier than you likely think. You'll receive concrete and teacher-friendly tips on how to incorporate it into your classroom. And finally, to wrap up with this series, an actual framework that you can use in your lessons, along with a real-life video of what story-based science experiment looks like. By now, you likely have a good idea that our secret weapon to teaching science to early years students is twofold: storytelling and play-based learning, and that's what we're going to cover in this module. Firstly, what is story-based and play-based learning? And second, how does storytelling and play-based learning promote science process skills? That is, observing qualities, measuring quantities, sorting and classifying, etc. Or, simply put, scientific and critical thinking skills. Our research strongly supports the idea that storytelling and play-based learning are the best ways to learn science and other STEAM topics. The purpose of story-based learning is this: imaginative moments and emotional engagement create strong, memorable learning experiences for little ones. When we use stories and play to support STEAM learning, we help children emotionally engage with the problem at hand and make it feel meaningful to them. Instead of simply giving the children a task, "Today we're going to learn about geometry. Here are some sticks and modeling clay, let's build a shape together," we tell them a story. Don't worry, it doesn't have to be anything too complex. For instance, there's a robot in trouble. This robot needs to reach somewhere really high, and he only has sticks and peas. Can we use sticks and peas to help him out? Adding the story brings commitment and meaning to the activity. A story-based lesson should always start with a story. However, the story time in the beginning is not the only place for storytelling during a story-based lesson. In fact, it should continue throughout the lesson. By doing this, we can best support child's critical thinking. That's why we refer to stories during science experiments. Remember, story-based lessons should always start with a story. That's where the research problem comes from. However, the story shouldn't be a separate phase in the beginning. As the facilitator, we should keep referring to the story during the whole investigation. This really keeps the meaning and commitment there. So, for example, during building something out of sticks and peas, we can then remind the little scientist about the story. Do you remember the robot problem? Do you think it's this structure we built out of sticks and modeling clay would help him reach the high window? Something as simple as this makes a big difference in the way a child relates to an experiment. At the end of lessons, we report our findings back to the story characters. For example, we can let the little scientist tell the robot what he could do to reach the high window. By keeping the story present throughout the lesson, we support the conclusion drawing process in many ways. Stories help children 1. Relate to the problem we are solving, 2. Get motivated to find solutions, 3. Remember the problem, and 4. Communicate about abstract phenomena in ways that are more natural to them. There's a reason behind the method of teaching children using stories, and that is because of the so important science process skills. Let's take a moment to think about something in science like solubility. Obviously, we cannot explain it to a little one on a molecular level, talking about atoms and hydrogen bonding and ion dipole interactions. What can we do? Instead of giving young children a fish, we should teach them how to fish in a way that they can really understand. In order to learn that skill, we need to start from the basics, science process skills. We'd practice, for example, observation. What does this substance feel like, smell like, or taste like even? Measurement, by counting spoonfuls, for example. Or interpretation, what do you think happened to the salt? And communication, of course. By the end of the class, the child won't be able to verbalize a full scientific explanation of solubility. And that's not our goal. Yes, you heard right. Now, this is a spot where many people lift their eyebrows and say, "Oh, children don't learn concepts. Isn't that the whole point of science learning?" As a matter of fact, they will learn about concepts too. Let me tell you why you don't have to worry. First of all, a deep understanding of a concept takes time. And we shouldn't expect a fully abstract understanding to happen in the early years anyway. Still, we can take the first steps on this journey by exposing the children to experience the phenomena and providing them the chance to give meaning to what happens. And guess what's in the foreground the entire time? A story. Even though a young child won't be able to explain what happened to the salt on a molecular level, they can still use their skills to help a character to solve the problem. Who stole the salt? Or did anyone steal it in the first place? We can make learning more meaningful by activating children's thinking with stories. The best way to do this is to practice science process skills in a story-based context. That's when the conceptual development starts. If you're framing solubility as something like, "Who stole the salt?" you're helping a child think, "Wait a second, who did steal the salt? Or did anyone even steal it in the first place?" It's okay when they can't verbalize a full scientific explanation of solubility by the end of the class. You know that, even though we seem to have this pressure with natural sciences. Deep understanding of concept happens through time. First steps of concept development are just as simple as having experiences of the phenomenon, and gradually, in time, we might be able to move to the more abstract levels of science. We support the first stages of concept development by focusing on science process skills. We start by observing with all of our senses. We measure to make observations more accurate, and we structure our experiences by classifying them into categories. We gradually move into interpreting our observations and sharing our thoughts to each other. A child who is a bit older might be able to predict what is going to happen if there's some previous experiences. But even a young child can help story characters figure out who stole the salt. These skills are so important to a child's educational development and often the most overlooked. By framing science lessons as stories, we are relating to children and making incredibly complex topics that much easier to understand. Through imaginative moments and emotional engagement, we can also create strong, memorable learning experiences. When we use stories and play to support science learning, we help children emotionally engage with the problem at hand and make it feel meaningful to them. In this learning environment, a child is truly an active learner, where their thoughts, ideas, and actions are at the center of the scientific inquiry. Hopefully, by this point, you're sold on story-based learning and the benefits it has on helping children learn lifelong science process skills. Thank you for watching this installment of the Masterclass. In the next installment, we will discuss the how of story-based lessons. Drama.